Alright, let's dance, Blue. Generally, we got this running, so we'll keep this going in the
Well, in
background.
this video, we're going to
I
talk about
wanted to bring in a
vector
little bit more of the
functions and
female
space curves.
interpretation here a little bit. Been
So
running
a
Leonard and Leonard.
vector-valued
Gray hair
function is
Leonard,
a
field
function
theory,
whose
classical
domain is a
mechanics,
set of real numbers
vectors,
and whose
derivative,
output is a set of
integrals on
vectors.
younger Leonard
Okay,
for
so let's
college
take a
classes.
look at
Setting up the
this
drill sergeant,
example.
NCO
So
field
on the left-hand
heat
side of the
vex
equal sign, we
field
have
theory
R of t,
for
and
him.
notice that
Setting
there's
it
an
up.
arrow over
Doing
the top
some,
of the
I
R
did
that
miss
denotes that
behavioral
vector-valued
psychology
function.
from
And
Stanford.
our
I was going to put
input
that one up in here, but I
is
don't have
t.
it in the set yet.
Okay, so the input, what goes
Okay, but I knew the
into this
capstone
function,
before I
our
want to start
input
started
is
here.
t.
Okay, so there's stuff about the math that's super critical inside
And
here.
that's what we mean
Okay,
by the domain.
you gotta
The
have it.
domain is
The
the set
domain,
of input
the field
values.
theory on doing it like this is a psychological thing. We're going to
Our
talk about
domain
that a
is set
lot
of
right
real
here.
numbers. So what we're going to put in is a t value that's a set
These
of real
are a
numbers.
lot of
And what
thesis
we get out is we get out
functions.
a vector. So on the
Okay,
right-hand side,
so
because
there's
we
a
have
couple of
vector,
different
we can
ways
write
to
that with
register
angle
vector
brackets
positions from a
notation or the
cosmological
IJK notation.
radiation
And
singularity.
these
The
pieces
singlet
here,
state
these little
on being
functions,
vector
the
positions
f
or
of t,
any
the g of
value
t, and the
from
h
those
of t,
topologies
these are all
have
called
measurements that are in
component
superposition
functions.
matrix to each other while trying to figure out organizations of
Okay,
field
so
theories
back
on the
in
stone mill floor.
previous work with vectors,
Here's the
we
tool
might have seen
shed,
a
all the
vector
L
like a vector
brackets
1, 2,
where they're supposed to
3.
be.
That's a vector, and 3. The
Pretty
components
good
are
over
1,
here
2,
about that
and 3.
spectrum
Now
being
we're talking about
hydrogen,
vector
helium,
valued
iron,
functions, where
y
the
some
x,
wave
the y,
function on
and
a
the
black
z
body
coordinate,
relative to
those are
numbers of
actually functions of t.
electromagnetism. Sophie Star, sorry
So
honey,
let's
I
take a
that's
look
how I
at an
do. Hope you don't mind.
example.
What I do in Leonard's class, I would be sitting there thinking in the class because I have most of this. I already know
Okay, so at
sine
the
and
top of the
cosine
screen,
to
we've got our
tangent
input,
values
real
in the
numbers. That's
stone
going to be
mill
our
because
domain
it'll
set.
come
What
at the
kind of real
front like
numbers
it's
can we put
tan
into a
army and
function?
numbers of
And then our
calculations
output,
across the board just
that's going to
popped
be a
up
set
in
of vectors.
superposition
So
sometimes
here's a
trying to
specific
play the manner.
example. R of t equals cosine ti plus sine tj plus tk. So for the first item on our list, let's figure out the vector we get when t equals 0. So n goes 0, what comes out?
Let's jump into this. I did a whole review on this. I watched this whole thing last night. I thought it was a beautiful marshmallow. A lot of times I pick up in the background in these autonomous things a lot of stuff I pump out when I'm cranking them out too. So there's a lot of brother stuff in here. There's a lot of competition stuff out here. Area of non-local topology that files specific desks based on graphs and terminal velocity. There's a lot of how that time decay state creates Einstein lensing crosses on Hubble's 45s for the invention of a telescope on those vector positions and spectrums.
Next, let's
So we'll get into that where that's a little bit more comprehensive.
Sine of pi is
Keep this in track.
1, sine of pi is 0.
Okay, so we'll keep it going out here. Calculus B. Here I want to bring up another female teacher before we bring up a few math teachers inside here, but I want to talk about the contextual model of the psychology of these classes. I want to talk about why this terminal is super critical. It's a whiteboard where analytical mechanics can bring out the Bob Rossi in you. This is going to be your happy bush. This is going to be, is it on fire? Is it not on fire? Is it raining today? What's the weather forecast of a mulberry bush if I need mulberries? What's the timelines on sine and cosine, neutrino factors, banging it up. Again, I had a chance to review some of this class. Love her methodology to start introduction. 63 megaparsecs to 73 megaparsecs. Pretty big differential to certain telescopes and how they do things. So I suggest you go watch. You're going to find a lot of the same computational models, but also divergent systems on stable positions of physics, which come up a lot in calculus lecture number 10 Supremo. But like I said, we're talking about some heavy-duty stuff in the same amount of time that covers very different information. I not take this off. I'm kind of run a system. I'll come back with this. Generally, while I was setting this up, I like to have that running, so that way I make sure that yep. We're still doing those kinds of systems, singlet states on this to this. The example or the text is going to cover the name and the definition or definitions, and any name of topology would define its endpoint, uncertain to those values without them inputting here. And if really that's what I want that to be when I get there, to output the mass and position.
but we can get the
position,
gist of
a
what
vector.
functions.
Some vector is what happens
when
off
t
of there.
equals
It
pi,
diverted
let's see, our
every
vector's
test,
gonna
or it
be
did something,
negative
starts to
1
get
in
out
the
of
x
home.
direction.
Second law of
That's
thermodynamics,
the
basically
base
sine.
here.
But it's
0
quantified in a
in
very
y
different constant.
and z.
And you got to break that constant sometimes to really understand that. That's what some people foul with in the first megaparsecs, to make that gap between general relativity and special relativity, and the analytical mechanics that's necessary here to really bridge the differential to find that need. Otherwise, you're looking at Fermilab, right? How do they make it? Magnets? Well, you have every combination way anybody else could have looked at this marshmallow and put it together to still have the results in timelines of vector positions of systems.
To help
We all got to do it.
visualize these vector valued functions, a lot of time what we do is we just keep track of the endpoints. Okay, so these are the endpoints. And in fact, if you were to plot infinitely many
Now, real quickly to
endpoints,
cover up
what
a
you
few
would
things here.
discover here is that this
From what we know about her
curve
behavioral
starts
sequence,
to look like
despite what her
a
defense
helix,
team would
and
later
around
want you
and
to
around
believe,
it
there's
goes.
virtually nothing in Jodie's childhood that can be linked as a contributing factor to what she would eventually be capable
like
of.
a
The only
coil,
thing
it
worth
coils
mentioning
right up
was that she
around
dropped out
the
of high school
positive
in the 11th
z-axis.
grade to pursue a career in
Okay,
photography,
we'll get to that in
but
a
it
minute.
went nowhere. So she began working at a hotel restaurant, which became her
So
occupation
here's this
for the
idea
next 8 years. In
formalized.
February of
Consider the vector
2006,
function
at 26
RT
years
equals
of
f
age,
Fiddle me
she
this,
began
Johnny.
a new
You think
job
you're
as a
good.
The set
salesperson
C of
for a
all
network
points
marketing
XYZ
company called Prepaid
such
Legal,
that
and it was
X
through this
equals f of
occupation
t,
where she
Y
crossed paths with
G of
fellow
t,
sales
and
representative
Z equals
Travis
H of t.
Alexander, a
That set of points is
28-year-old
called a
practicing
space
Mormon
curve.
from
And
Arizona.
Well, we're
She
going to
also
talk
worked
about
part-time
this
as a
whole
motivational speaker.
area, not just Jodie.
Okay, so let's plot the space curve defined by r of t equals cosine t sine t t, for t going from 0 to 2 pi. So notice that there's a start.
Now,
There's a stop.
I bring up Leonard to this special case because of two other ones we'll bring up in a moment.
They met at
We
a
are going to
business
start and
conference in
stop at
September
some
of
particular
2000.
t values.
Okay, so we got a
You
lot
can
of stuff
imagine
going
there's
on
like a
here, yeah?
computer animation and like a
Let's
little
listen to it a
dot
little bit.
or a little Pac-Man or some sort of video game creature that's scooting along the screen, right? And you're going to start it and stop it at particular time equals 0 and time equals 2 pi. Right,
This
so
is
our
tough
example
because
from up above.
when you are separating these things, you have to be very analytical.
Use polar. If the region you have
And
to
just to
work with are
remind you, we
lines
plotted
and
this, but we plotted it as a
But
vector function.
to take these
and
out
there's
here for a
tons of
moment,
vectors, infinite
just
many
to
vectors,
pop
so
it
many
back to
vectors,
some
or
reality,
pictures
give
of
you
an
some
S.
places
And
to
really
point
what
where I might be
your
going in
mind
here.
can understand what's going
That
on
would be
with
the
all
same
these
person
vectors, too
that
many
did
vectors. So what
that
we
case
do is
over
we
there.
just
What would
keep
you
track
expect
of
this to
the
be like?
endpoints of
And you're
those
going to learn a
vectors.
lot
That's
from
our
those
space
types
curve.
of incidents
Okay, and
when
that's
these
what
things
we
happen
wanna
on the floor.
plot now. We want to plot that space curve.
So while we have those things in mind
Because
about those
video game
of
creature,
conceptual
moving
models,
along the
we're going to do
screen
something here.
according to this
No offense,
function.
honey. Like I said, I'm
You're
letting him
gonna
go for a little bit
start and
because
stop it. What's the path it
it's
takes?
real big here
Time
and it
equals 0 to
happens a
time
lot
equals 2.
because students have
Right. Well, in
E
general,
negative
what's gonna
function
happen
or
is
an
this
angle
looks like a
or a spin or
helix as it goes around,
some
and
graphing
it's
danger
wrapping
noodle
around
inside
that
here
log
that said
z-axis and up and
all
up
that.
it goes.
Okay.
And it goes on forever if we let it go.
Our job
forever.
figuring that out.
Now we are told to
This one?
start
Yeah,
and
here we go.
stop this.
Now here's another version
at time equals
where you will
0
still
to
see
2 pi. I have started it at 0.
not a differential. Sorry,
Let's figure out where does it end.
not a differential necessarily of anything you would find different that actually, if you separate it, is useful and interesting to determine the mass value of a 3-dimensional, 4-dimensional, 2-dimensional, 1-dimensional Sophie star out here making a vector position of what type. Is it calculus? Is it classical mechanics? Is it calculus 3 lecture into double integrals to begin with on some of these stuff?
And then we don't keep going, so we are going to
Okay, let's take this down again. And I don't mean to take away from what I feel to be very good indicators of how different ways to go through this while going off the mountain into other people's functions and how to deal with that type of terminal, that type of garden landscaping path. Okay, so let's knock some of this out here. I suggest you go ahead and do that for some required reading for the class, what I've put up here today. Think about how long it'll take you to do it. Is there homework in this class over here? No, a lot of that's going to be based on what you could do up here, and I want to show you why. Because the life experiment about this, do I bring out a whiteboard now? Who told you? Double integrals, nobody told you to do it, so you didn't do it? I'm telling you. Let's get these out of here. Those are very good classes. I usually watch 1 or 2 of them a night. Which ones of those while I'm going through their honeycomb matrix, looking for the treasure and the marshmallows. So let's just skip over to this one here. I think that was the answer there. Alright, yeah, no, so that's the hard one. And I bring up this concept because this is one of the STEM Millennium math problems.
Okay, thank you.
And fairly important while I got a short time to put this back down.
This talk kind of comes out of the following. So,
Now,
in the mid to late 1980s, a certain badass Russian mathematician named Viktor Kolyvagin made a valiant attempt to prove the Birchon-Swinnerton diagram.
this is life, no matter how you cut
curves
it.
with analytic rank 0 and 1.
And I go back through this, through all of it, and line them up different in here in the same matrix.
And so on. And
So, I usually make the joke about the concept of where I learned this specifically from this when I am talking about the topological model psychologically is walking up to this billboard, brick and dryer conjecture using, and I said it the way I said it. Yes, obviously that is the answer. Brick and dryer conjecture will be how well you handle this and that object banging around in here. This is a heavy course talking about a lot of different indexes of many different types of combinations in a crypto, dark web, blockchain, chain rule, lockdown, fascist math. And it is, even though it'll look like the hot plasmic state of the universe in the background. And I choose this one because even though it's in the same tone as what those do, the value is different. However, the enrich of a type of design where it's more comprehensive than the original standard stands out some mathematicians. Stands out some people that have a study of an index of functions that were out there before and whether they've been truly tried and exampled in every form of the matrix while going through a very heavy comprehensive system of what this does. And you're going to get into a bunch of different fields. These two things are not just those two things switching back. It's going to get heavy. It doesn't play any difference, honestly. But the differential here is something he's going to catch you with if those students come in and hear about not putting the N1 half or her not putting the N1 half. If the homework assignments or the course, with me being with respect to X here, about any topology of how that functions inside here, would be the same timeline and thesis. Okay, so you got to find yours. Sometimes it's in the stone mill. Sometimes it's just hunting in the woods. There's always the river, right? There's always landscapers maps, carpentry, MOSs across the board, applications and functions of fractal, Mandel fractals, and Dirac equations, things popping up, dealing with the real after that vector position is applied in general. So this is your example. In my class, you would be taking turns as a nuclear reactor of neutrinos colliding on the surface to enrich the black hole to do a thing, and I'm going to make you worth the money because it shows you some skills along the way.
For particular examples,
Catch you on the next one.
is known for particular examples only.